Hello, in today's video, I'm going to discuss 5 facts or theories about space that will leave us, at the very least, very surprised. So let's dive straight into the 5th place. Living in space would have a devastating effect on our bodies. Astronauts lose decades worth of bone mass in space, and many do not fully recover even 1 year after returning to Earth. Without the constant gravitational force of Earth on our limbs, muscle and bone mass quickly start to decrease in space. The most affected are the muscles that help maintain posture in the back, neck, calves, and quadriceps. With microgravity, these limbs don't need to work as hard and begin to atrophy. In just 2 weeks, muscle mass can drop by up to 20%. In longer missions of 3 to 6 months, the loss can reach an incredible 30%. But it's not just the muscles that feel the lack of gravity. Bones also atrophy for the same reason, akin to osteoporosis. Aboard space stations, astronauts need to dedicate many hours a day to physical exercise, trying to limit the damage caused by the lack of need for more intense musculoskeletal activity. Some studies indicate a loss of between 1 and 2% of bone density for each month spent in space. There are also reported skin rashes, gas, dehydration, irregular heartbeats, and various other problems by the Apollo 11 crew. In 4th place comes the controversial dark matter and dark energy. Atoms make up everything that is known: planets, stars, and even human beings. Yet, all of this represents only 5% of the entire universe. The rest is formed by what scientists call dark energy and dark matter. Since the 1930s, we have known that our universe is expanding, and according to Einstein, the matter contained in the universe tends to decelerate this expansion. By the end of the 20th century, we discovered that the expansion of the universe is not decelerating, quite the opposite. It is accelerating. Distances between distant galaxies are increasing at an increasing rate, and in the context of Einstein's general relativity, this is not possible if the universe contains only matter. This indicates the existence of an additional component, a form of unknown energy that has negative pressure and neutralizes the attractive effect of gravity, driving the accelerated expansion of the universe. Deciphering the nature of this component, we call dark energy, is one of the most important open problems in current physics. As for dark matter, it is a form of matter that does not interact with light. Its presence is detectable only by its gravitational effects on the formation and evolution of structures in the universe, such as galaxies and clusters of galaxies. Ordinary matter, made of atoms, constitutes less than 5% of the total energy of the universe, and other components, such as neutrinos or photons, have much smaller contributions. Like ordinary matter, dark matter helps slow down the expansion of the universe, that is, the opposite effect of dark energy. Another important difference between these components is their distribution in space. Dark matter exhibits fluctuations in its density that grow over time, with denser areas acquiring more and more matter due to their gravitational attraction. Dark energy, on the other hand, appears to follow a uniform distribution, with the same density in space. Before moving on to 3rd place, I need to ask you to leave us a like. It's very important because besides enabling the continuity of the channel, it allows me to invest in better narration and more time for study and development of the texts. So, with your like, the channel grows and improves. But let's move on to the 3rd place. 3rd place is occupied by black holes. Astronomers and physicists often define black holes as pockets of extremely dense matter, objects of such incredible mass and minuscule volume that they drastically distort the fabric of space-time. It's a region of space where the gravitational field is so strong that not even light can escape. To begin to understand black holes, we need to go back to Albert Einstein's general theory of relativity when he proposed that the universe existed in a 4-dimensional geometry known as space-time. He introduced the understanding that time would also be a dimension, making it relative. But this was not enough to explain spatial phenomena, so he included gravity as an important quantity which would depend on the mass of objects. The presence of bodies with significant mass would curve this space-time. The more mass, the larger the field and the distortion of time and space. In practice, this means that in the Sun, for example, time flows slower than on Earth. Einstein managed to predict the existence of black holes in 1916, but at that time, he himself did not have much faith in his calculations and struggled with the consequences of his theory. In 2nd place is the theory of the cyclic universe. The most accepted theory to explain the emergence of the universe is the Big Bang, an explosive event that supposedly occurred 13.8 billion years ago. But this theory says that the universe as we know it will end in a collapse. And the cause is a mysterious energy that is currently accelerating the expansion of the cosmos, but in a few trillion years, will do just the opposite. Then we'll have a new Big Bang to restart the whole process. According to scientists, the cosmos would have been born from a point with such a strong gravitational field that concentrated all of spacetime and the energy of the universe. But what if instead of being born from this point, the universe was something that has always existed, and that after a certain time and space, returned to the initial point and restarted the process? This theory is not new, and with its over 70 years, it discusses endless sequences of big bangs and big crunches, which never had a beginning and will never have an end. And finally, in first place, we have the star Tabby. Any celestial body that orbits a star causes a regular variation in brightness, which does not occur with this star. The brightness variation shown in telescopes has so many irregularities that it has been speculated that only a mega extraterrestrial construction could explain such behavior. But a new study has brought some good evidence that it's not artificial. In fact, there are explanations of natural events that could cause this behavior in the star. Since 2016, a team from the University of Arizona has been studying the existence of a second star that would exert a gravitational influence on Tabby's star. The study of this binary system took 5 years to complete but managed to show that it is a gravitationally bound stellar duo. The two stars are separated by a distance of twice the distance between Earth and the Sun. The larger one has about 1.36 times the mass of the Sun and is 1.5 times the size of the Sun. And the smaller one is a red dwarf with about 0.44 times the mass of the Sun and 0.45 times the size of the Sun. Researchers say there's a chance the smaller star may play a role in the larger star's mysterious oscillations. And you? Which of these facts or theories do you believe is the most interesting or mysterious? Do you remember another fact or theory that should be on this list? Comment below and don't forget to leave a like. Your like costs nothing and helps us a lot to continue. Thank you, and until the next video.